Hey, today we're going to be talking about 5-7 corresponding parts of congruent triangles. Okay, so I know we all know what congruent figures are. Corresponding parts, we've talked about that. And we know what a construction is. We're going to kind of put all those things together to do kind of an additional proof here. So what I want to start with is see how you guys would go about, this is page 156 of your student journal, how you all would go about proving that UV is congruent to XV. That's number one. Explain how to prove that statement. Probably the best way to explain it is to go through and think about how you would write up a proof on it. Okay? So what would be the statements? What would be your reasons? You don't have to get real specific, but okay? Specific enough so that we know. And if you actually just want to write it as a proof, you can, but do your best there. Now, those of you struggling getting going on this, I would start by proving two triangles congruent. Okay? Start by trying to prove two of those triangles that contain those sides congruent. Hey, was anyone able to prove two triangles congruent? Maddie, how'd you do it? Line TV congruent to line VW. Okay.
And then angle VWX congruent to angle VTU.
Okay. And in this case, I'm just going to use angle TW or angle W and angle T just because they're the only angles there. So both those are given. Okay. And then what?
And then I did angle TV is congruent to angle WVX because it flexes.
Okay.
And I did triangle VWX is congruent to triangle VTU because AS.
Okay. VWX to VTU. And AWA, or ASA, excuse me. All right. Everyone agree? Question?
Wouldn't the second one be vertical angles?
Yes, that would be vertical angles. Good. Okay, so we'll fix that up. Vertical angles on that one. Way to go, Brian, and way to be Brian's spokesperson. All right. Okay, so we have that. We have two triangles. Now, that's not what they ask. They want that UV is congruent to XV. How do we do that? Drew?
Can we include that statement in your proof to prove the triangle?
Yeah, you could, but you'd actually you can't actually prove that until you know that the triangles are congruent.
Okay.
Yeah. Carson?
Right, I said corresponding parts on congruent triangles are congruent.
Yeah, corresponding parts. So let's write that out. The reason is corresponding parts of congruent triangles are congruent. That's not too bad to write out, right? Corresponding parts of congruent triangles are congruent. Now, since that is actually a pain to write out, we actually abbreviated it as C. What's next? P, C, T, C. Corresponding parts of congruent triangles are congruent. We don't put the O and the A. If you want to, because that bothers you, you could put. All right. Corresponding parts of congruent triangles are congruent. CPCTC. There we go. That's the final statement. So just one more step, just because it's fun like that. Yeah. All right. Questions? Give number 2 go. And number 3, please. 2 and 3. And you can just write it. You didn't have to do a formal proof. You just say your statements in parentheses, put your reasons after it if you want. That's probably the easiest way. Okay. All right. There's some of you that are stuck here. Let's go back to our five ways to prove triangles congruent. What's one? ASA. What's another? SSS. What's that? Okay. Okay. There's one left. HL. HL works with what types of triangles? Right triangles. Hypotenuse and leg. Okay. So you guys, on this one, you'd have your givens. Like if I'm going through my reasons, I'd have my givens. And then from there, I'd have to use all right triangles. Or excuse me, I'd have to state definition of a right triangle. I'd have to say that these are right triangles. So we have the givens, and we state that they're right triangles. And then, after that, I could use what theorem to state that they're congruent? HL. So these are just my reasons, mind you. I'm not listing my statements right now. So the givens, definition of right triangles, make them right triangles. I now have hypotenuse leg, they're congruent, and then I can use TS to VR by CP, CT, C. Okay? So in more of a, like in a format that actually has the statements in there. Let me put that up there for you. Okay? I would focus on the outside. It'd be a little better, but sorry. All right. Cool. This was the one that a lot of you are missing, was the HL there. Okay, you guys are kind of scrolling through all your congruent statements. That one wasn't working. All right, last one, at least before we dive into some different types, I guess. Number 3 there. Give that one a go. I think this one's a little more direct, isn't it? Yeah, I don't want you to do a bunch of busy work. What are the reasons here? Go ahead, Jeremiah. Okay, so we have our givens. That's one reason. Okay, what's another reason? Vertical angles. No. Sorry. Are you thinking these two? Yeah, in vertical angles, remember it would be this one to that one. You have to extend those lines. Okay, so those are not vertical angles there. Nope. All right? Yeah, Maddie? Yeah, you can just go side angle side from there. There, 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 there. And then from there, we can use CP, CT, and C. Cool, man. Very good? All right. Hey, take a look at number 4. This one's a little more complex. Okay? Write a plan to prove angle 1 is congruent to angle 2. Now, a plan to prove, you can just say how you're going to prove it. Okay, say, well, I'm going to prove that this is congruent to that by this, and then state that this is that, this is equal to that or corresponding to this, and then I can use that to prove that angle 1 is congruent to angle 2. Okay, so just talk about it. You don't have to write a big statement out right now, but go ahead and talk about it with your neighbor. Tell them how you'd prove it. Okay, so what are some thoughts? This one isn't quite as direct. Sam? Okay, so using your givens. Okay. So part of our given. So what are we going to do with those? Yeah. Use them for what? You're on the, okay. Yeah, I mean, that'll be the very start. Maddie? Which two triangles? Okay, so just so that everyone sees it, Maddie's saying, hey, we can use it to prove that this triangle is congruent to the one that's not shaded there, right? So triangle, so GIH to triangle IGF. Okay? By what theorem? Someone else. Yeah? Yeah, angle, angle, side. Now, we'd obviously have to state a lot more than that. Like, we'd have to talk all right angles are congruent. We'd have to talk about two sides being equal. But eventually, like when we're just stating a plan, we can say, hey, we're going to use our givens, and then we're going to prove that these are congruent. Okay? We'd have intermittent steps. All right angles are congruent. We'd have to state that, hey, this angle or this side and this side, okay, they add up. Okay, we could go through all of that. But right now, really, we've got that guy right there. Okay? Everyone from there, I want you to keep going. Okay? I'll be right over there. Go ahead and go. Let's go ahead and finish it up here. So if we have these two triangles congruent, I'm going to erase this chunk here. There's a couple ways we can do this. This is probably not the most direct way, but you could then prove that this triangle's congruent to that one, because you now have this side is congruent to that side. Right? So you have by angle or side, angle, side, those are congruent, and then you could say angle 1 is congruent to angle 2 by CP, CTC. Okay, you guys, probably the most direct way to do this, though, and Hunter and I were just talking about it, probably the most direct way on this is if you look at this line right here, this line that cuts through these two lines, so line GI, what is that line called? That is called a transversal. Okay? And when you have these angles congruent in a transversal, what are these lines? These are parallel lines. So I would probably go about saying, hey, these are parallel lines. How do I know that? Based on my given statement. How does that help me? Well, if those are parallel lines using that transversal, I'm going to erase that transversal now, and I'm going to use another transversal. Since I have parallel lines, I know that alternate interior angles are congruent. That would probably be the quickest way. I mean, first state they're parallel using the givens, and then use parallel lines and alternate interior angles to prove they're congruent. Yeah?
So you know the lines are parallel because of alternate interior angles?
Yeah. You know, remember when we study parallel lines, when alternate interior angles are congruent, which we have, then the lines that transversal cuts through are parallel. Okay? And then once we use that and state that they're parallel, then you go back the other way and cut it with another transversal and say, hey, those are parallel lines, therefore, these two alternate interior angles must be congruent. Okay. Good conversation with that, honey. Okay. We are going to call it good right there. Any questions? Guys, I will put up the answers here in a minute if you want to look at number 5 and 6 on the next page and just do a little more practice. I'll put those answers up under the document camera here in a minute. But I'm going to go ahead and give you your assignment. You guys can talk about number 5 while I'm doing that, maybe even 6. Just look at it, okay? Might help you out a bit. Okay, so those of you who want to see those, there's number 6. You use side, or number 5, excuse me. You use side, side, side to prove ABC congruent to ADC. And then you could say ACB is congruent to ACD, or angle ACB to ACD by CPCTC. And then angle 1 congruent to, or use that to prove your other triangles, BCE and DCE congruent, and then angle 1 to 2. So using multiple triangle congruence there. And then the last one, you'd have your givens, and then the reflexive property. And then triangle ABD to ACD by side, and BAD to CAD by CPCTC.